we're going to shift gears a little bit again, moving to the physical responses of the Back Bay to the breach. And I guess I'd like to preface this talk by mentioning that in response to that 2001 report that New York Sea Grant and others put together, Sea Grant decided to dedicate some funds to a special focus area in the years 2004 to 2006. This was part of our regular call for proposals, but we wanted to dedicate a certain amount of funding specifically for that to try to help answer some of the questions that were raised in that report. And one of the studies that was funded was being conducted by Charlie Flagg and Bob Wilson, that was mentioned in Henry's introduction. This was a 2004 study of physical responses. So trying to model what a breach would be like and what a breach would do to the characteristics of the water. So we're hoping that Charlie's going to talk some about that, but also as well about some of the new modeling that they're doing now. And the presentation is going to be split between Charlie and Bob, with Charlie talking about the salinity and the temperature factors, and then Bob Wilson will be talking about the storm surge. So Charlie.
One comment about that early model. That was done 2004-05 period. It was done with a somewhat more primitive version of the model, and we assumed that the inlet was going to be the size of Little Pikes, which is about 5 times bigger than the inlet as it exists now. So our estimate of impact on salt and salinity and tide ranges don't really apply to the inlet as it exists. So anyways, we're trying to work on that in the near future. So in this part of the discussion, we're talking about what's happening on the inside of the Great South Bay as a result of the breach. And again, we're relying on the data from the the Great South Bay Project's observatory. And our main instrumentation is a Seabird Seacat that measures temperature, salinity, and water level. And this little guy measures chlorophyll and turbidity. And we put it in like this, and we usually get it out like that. So there's usually some sort of degradation in the quality of, especially of salt. So sometimes you'll see that there's a bit of a tail off occasionally in the salinity records. All this data is on our website. This is the delayed mode data. We have real-time data from Bellport, which we put in as a result of Park Service funding. And there's a Great South Bay buoy, and that is also now supported by DEC and the Park Service. So this is what the buoy looks like on a particularly placid day. There's usual sort of a meteorological instrumentation, wind speed, direction, air temperature, humidity, solar radiation, and then we have a Seacat deployed below the waterline, and this is all telemetered essentially near real time at about half-hour intervals, and it is available on the website. Last year we had a rather interesting ice impact. In the past, this buoy has been caught up in the ice sheets and dragged from Islip to Sayville and back again, and but last year it got drifted over toward Fire Island in the shallows. It got rolled over, turned upside down, and all the instrumentation was ruined. And the ice rafted it about 10 miles to the east, and it ended up on the shoal of the inlet, which is rather ironic. Anyways, it has taken, we recovered it in April or March, and it took until September for us to get it back in the water. It's now back in and reporting data. So one of the immediate interesting things, the questions come right away about what the impact of the inlet is in terms of tides and storms and salinity. So the basic result is that the M2 tide, the primary semi-annual tide in Great South Bay, has essentially not changed. It's only, this is the range, so it's about a foot in Bellport. It's a little bit more than that at Tanner Park. The U.S. Coast Guard base is a little higher yet. The ocean is the range is about a meter. And you can see that before and after, there hasn't been much of a change. If we look at, here's a little more detail at that. We had a summer student, and he took the records from Bellport and Lindenhurst and chopped them up into sort of 40-day increments throughout the year, well, throughout the record, and then ran a tide analysis on it. And so this is the results from that. This is from, again, the M2 tide at Bellport. We have the amplitude, which is half the range, and the phase in degrees. And there's a correlation coefficient, or the regression coefficient for the fit, and 95% confidence interval is 0.54. So in terms of the this fit, this is in Bellport. This is not a significant increase. These lines here are on this particular picture that's 1 centimeter. So there's even if this was significant, it is not much of a change. The red line is when Sandy occurred. And the pink lines are the 95% confidence intervals for these numbers. So basically at Bellport, the amplitude hasn't changed, but the phase has. And there's been about a 10-degree change in phase over the 18 months of this picture, which is about 20 minutes. So the tides are happening 20 minutes earlier at Bellport as a result, possibly, of the inlet. This is at Lindenhurst, again, for the M2 tide. There is a significant increase in range at Lindenhurst. However, and it is significant, after March or April of 2013, it's remarkably constant. And this is the period when Fire Island Inlet was being dredged. So it's a little unclear what's happening here. It's tempting to ascribe this change to the dredging, but may or may not be the case. There's no significant variation in phase, and it's rather wildly varying. Each of these lines are 20 degrees, so this is plus and minus 20 minutes or so. So there's large changes, but I'm not sure exactly what's going on there. The next largest tidal constituent in both of these locations is the K1. This is a diurnal component, and it's about 20% of the M2 tide. So it's a relatively small thing. And in Bellport, neither range nor phase have changed. And it's actually rather tempting to think that the diurnal would change, since the inlets are low-pass filters, and this is a lower frequency process. And so you would think that if we had opened up the things, it should show up at least on these diurnal numbers, but it doesn't. And it's essentially the same. Well, at Lindenhurst, we get an increase in phase, but it's rather variable, but it is significant. And so this is an increase in amplitude, of about 2 centimeters. There is also the change in phase is not significant. but it looks like, again, it's happening slightly earlier at Lindenhurst. So Lindenhurst seems to be the area that's affected most. And it's at the western end and as far from the breach as you can get, so one wonders about whether the breach is having any impact. We've done a velocity survey. We don't have such quite sophisticated equipment as the USGS. We put a ADCP on the bow of our little skiff, and Bob Wilson and I spent 12 hours going back and forth across here for 70 sections, and we're able to estimate the transport through an entire ebb cycle from slack after flood to slack after ebb, and this is the transport in meters cubed per second. The maximum currents we saw are about 5 knots. The maximum transports are about 450 cubic meters per second, and the total transport is about 7 million meters cubed over half a tidal cycle. So if you look at what that impact is on the bay, it turns out that the tidal range at Bellport that day was 39 centimeters, and so you can estimate the coverage of that flow, and it turns out to be about 18 square kilometers. And 18 square kilometers is almost exactly the area of Bellport Bay. So Bellport Bay is 18. The total of Great South Bay in this green area is about 200 square kilometers. So it looks like the inlet is able to deal with or supply about 8% of the tidal range in Great South Bay. So the bottom line here is that it's relatively small potatoes, which explains why, even though there has been a breach and even though it has increased in size, there haven't been increases in tide range in the bay as a result of the breach. We've looked at salinity. This is a record from the Suffolk County hydro stations. Their Department of Health Services have been collecting these since the early 80s as a result of the brown tide. And so if you just look at the two stations within Bellport Bay, one is right near Carmen's River, so it's going to be pretty fresh. One's off Howells Point, so it'll be a little more like representative of the bay. And the ocean here, Station 220. So the ocean is around 31, 32 parts per thousand. Historically, Bellport Bay has been in the order of 24 or 25 parts per thousand. This is the record for the first year at Bellport, and the green line is at the Great South Bay buoy. And so here's Hurricane Sandy, and you can see that there's this big jump. And so it's highly variable near Bellport because it's near the shore, and Carmen's River and Beaver Dam Creek change the salinities a lot when there's a storm. So that's what this is all about. But typically it looks like the salinity is around 28. We had this huge rain event in June of that year, and it dropped it, and it took a long time to recover. Interesting, in this March-April period of 2013, the salinity at the Great South Bay buoy climbed up. It hadn't been affected by the inlet until this March-April period, and then it climbed up. And it was also affected by this rain event. And then after the Great South Bay sort of recovered from that rain event, the buoy and Bellport are in the 28 to 30 parts per thousand range, and that continues now. This is these are two pictures I downloaded this morning from the website, and so here's Bellport's real-time observations and the temperature salinity from the buoy this morning, and this panel shows salinity, and here's 28, and that's 30, so it's been oscillating around 28 to 30, closer to 29 or so. for the past, this is a 60-day run. This is the buoy, and it is almost, looks like it's hardwired at the 29 parts per thousand. So the impact of the combined impact of the inlet and the dredging at Fire Island seemed to have increased the bay salinity significantly. Although, if you look at Tanner Park, which is half again to the further west, those kinds of salinities are typical. So here's Tanner Park in 2010-11, and this is salinity, and it's a little over 30. This is the 30 parts per thousand line. There are vents, obviously, that lower it. But Tanner Park is typically 30. This is Tanner Park. We recovered this in just a little while ago. And so there was a certain amount of biological fouling, so we cut this part off. And this was this weird rainstorm we had in August. If you recall, there was a 10-mile wide, 10 inches of rain that ran across Long Island. And my house in Bellport, we got half an inch of rain, and they got 10 inches of rain. Anyway, so that's what this is. This isn't an instrumentation failure. This is just that rain. But anyways, before that, it was in the 29 to 30 parts per thousand, which is essentially what it's been. So the western end of the bay, there hasn't been any change in salt. That's the bottom line. Just a brief discussion, I mentioned it earlier, and that is the bay responds to the winds in two ways. One is this virtually instantaneous downwind drift of the wind of the water, so that there's a balance between the pressure gradient and the wind stress, and that's represented here, and that happens within a couple of hours. The setup or set down on the coast takes a while. In the ocean, takes about 10 to 20 hours to respond, and it takes a little bit longer for that response to get into the bay. And this is a response curve showing, if you look at the slope of the water level between Bellport and Lindenhurst, you get this peak that's only a couple of hours, and it's comes from the in the Long Bay direction. In the and if you look at the total the water level, the average of Bellport and Lindenhurst, you see that it peaks again from about the same direction, about 25 to somewhere in this area. So there is this two frequency response of the bay to wind events. The other one is whether or not it has led to flooding, and I think many of you guys have seen this by this time. We've looked at water level records from Woods Hole at the eastern end of the Great Mid-Atlantic Bight, Bellport, Lindenhurst, Atlantic City, and Chesapeake, and the picture I'll show, it just has these three. Atlantic City and Chesapeake look essentially the same. So this is the detided water level records from the three sites, Bellport, Lindenhurst, and Woods Hole. And this is Sandy, and this is, I've changed my units here, this is feet. So this is Sandy, and Lindenhurst had by far the highest response. Bellport, or Woods Hole Bellport is here and Woods Hole is down here. But the point is that these big events that we had all during that fairly stormy spring happen throughout the thing, and Woods Hole responds equally with all the other guys. We even had a major nor'wester, and the water levels dropped everywhere, although nobody seemed to be particularly excited about that event. This is I gave a talk on Tuesday night to the marine industry for Long Island, which runs the marinas and things of this sort. So they're really down at the water's edge. And one of the points I made was water levels going up, This is the this is from an IPCC report. The water level has gone up by about 8 inches in the last 80 to 100 years, about this far. And these are the projections for the future. If you think that your fellow citizens are going to be very responsible and cut back on their CO2 emissions, then you can follow this blue line. If you're more pessimistic about their response, you can follow the red line. Anyways, in 40 years, we're going to have essentially another foot of water throughout the area. So if you go back to these things, while these storms were rather unusual, if you add a foot to all these guys, these 10 to 100-year storms are going to be 2 to 10-year storms, and so the flooding throughout the Mid-Atlantic Bight is going to be much more of a thing. So that's where we stand at the moment. That's what the response of the bay has been to the inlets. Any questions?
Bob mentioned earlier, and I think you might have mentioned that we really have a 3-inlet system, and we obviously, USGS and your program has been doing a lot to understand the bathymetry changes of the inlet, the flow changes of the new inlet. But with all the dredging going on in the other inlets, what information is available to do these comparisons and better understand what the impact is?
Well, I'm afraid I'm going to have to ask Jay. He's tried several times to get detailed bathymetric before and afters for the inlets, and what's the story, Jay?
Well, what I've done is found out what they have done and where you can get the information. I haven't tried. I think what we are going to have to do, and I guess the USGS now has the bathymetry in Fire Island Inlet, pretty detailed resolution, is the Corps has been doing the dredging there. So there's a big question about whether it's really affecting where they're dredging, how much they're dredging, and whether it's affecting the Flagg or the narrowest part of the inlet and causing some of those changes.
The dredging seems to have two purposes. Some of it is they grab sand in order to build a dune. They're not actually making the inlet bigger. And other times they're making the inlet bigger, and I'm not sure what they're doing with the sand. But so these things don't happen at the same time. So just because they're dredging doesn't mean that it's getting bigger.
That's something we have to figure out, and then you'll be able to plug that into the model and take
Right.
a look.
Right.
In one of your earlier slides, you showed a graph of the tidal dynamic data for Belport Inland and Hurst after the storm. But have you ever plotted what it looked like the last time Fire Island Inlet was dredged?
No, I have not, and I'm not sure when it. That data I just don't know. I don't know when they last did it.
I think it was about 10 years ago.
Well, our whole system only went into water about 2005, starting in Belport and sort of worked its way west. So we probably don't have the data prior to 2005 to tell you.
One thing about the M2s, have you compared what was happening in the ocean at the same time for those M2 tides to see if there's a change that's occurring in the ocean that may be also responsible?
No, I haven't. So the question was, has the M2 or any of the tidal constituents changed significantly in the ocean during the same time period? And no, we haven't looked at that. It's a little embarrassing that there's the only records of water level records in the ocean are at Sandy Hook and Montauk, and we're in the middle. It would be not that, so anyways, it's reasonable to take the average of those two, but there is some differences. So. Okay.
Charlie, the long time lag after a major precipitation event with salinity, it shoots down, then takes 1 month or even 3 months to come back again. That seems much longer than the residence time that's given by the models. And I'm just wondering, is some of that due to be the nature of Long Island, that precipitation sinks into the soil, and then there's an upward flux of fresh water within the bay, and much like Henry's been looking at for years and years, which keeps the salinity down longer than the circulation and
Well, I think that's a good point, and yes, under normal circumstances, not including these big rain events, about half, we estimate that about half the fresh water comes in as part of groundwater. So after a rain event, when you raise the water table, then it's going to take some time for it to drain. Water goes nominally, what, a foot a day in the groundwater? So it's going to take a long time to flush it all out.
Charlie, a question, and this might relate more to your previous talk than this one. The remnant old inlet dock, I believe that was swept out, washed away what was left of it in winter of 2013, 2014. Unfortunately, there goes our platform to put instruments on. But
Yeah.
that seemed to also coincide with some of the changes just coincidentally, may have occurred when we had some of the changes in the bowway geometry and some of the spit formation and demise. Do you have any data, or do you have any hypotheses as to whether the dock may have been a bit of a control on breach evolution during that time, and now that it's gone, it's allowed the breach to evolve in a different way?
Well,
different trajectory?
what was happening with the dock was highly variable. Sometimes it was covered, not covered, but the sand was almost up to it. And then the next time we'd go out for a bathymetric survey, it would be, the water was rushing through it. This was the main channel, was going right through the dock. And so it changed month to month, certainly, maybe even faster than that, but we were only out there at month intervals. So my feeling about what the control of the inlet size has always been that the flood delta was restricting the access to the rest of the bay. And the opening of the inlet, now that's increased by something nominally 50% or something like that, is due to the fact that the main channel, this northwest-southeast channel, has almost fully developed. At the northern end, it's about 1 meter deep. And so, it's still pushing north. It's 4 meters in its deepest spot that we saw. So the restraint on the inlet from the flood delta seems to be decreasing.
I think I'd like to thank Charlie also for his really excellent informing of us. The various sponsors have funded this work, Sea Grant, Park Service, DEC, and he sends us periodic reports with photographs and data, sort of an update on everything. And so it's really been helpful for Sea Grant, and I'm sure for the others too. So thank you, Charlie, for doing that. It's kind of unheard of in a way for a lot of researchers to be doing that. But
That's what he's been here.
Yeah.
It's very helpful. And this data, actually, the salinity in particular, and the temperature as well, important for the biological studies that we're going to be talking about later on this afternoon. So a lot of those researchers have been taking their own numbers of salinity and temperature and trying to use that to help understand what they're seeing, but certainly correlating with what Charlie's gotten and others